Hi everyone, this is S. Lakshmanachari, working as Assistant Professor in the EC Department, Institute of Aeronautical Engineering. Today we are going to discuss how to interface analog to digital converter with 8051 microcontroller. So click on Start, double click on the Keel Microvision 4 software. So select the project and click on New Microvision project. And then create a folder on the desktop. Give the file name. So I am giving the file name as ADC, analog to digital converter, and open and give the file name ADC. Click on save, and after that it will ask select device for target. So here it will show different types of microcontroller manufacturers. You can select any family, any manufacturer. So I am selecting NXP. So in this I am selecting P89V51RD2. After selecting the desired microcontroller, click on OK. So it will ask copy startup.a512 project folder and add files to project. So it is asking to add the startup file to our project. So because this startup file is required when we are writing the program in the C language. When we are writing the program in the assembly language, the startup file is not required. So click on S, and when you click on S, that startup file will add it to our project. So you can see here startup file already added here, and then click on File, New File, and write the program. So the first line is the hash include register reg 51.h. So this is a header file of the 8051 microcontroller. So this header file, it contains all the registers, and then hash define space input P2. So I'm defining port 2 as the input. Next, hash define output P0. So I'm defining P0 port as the output. Next, S bit write is equal to P1 cap 1, P1.1 colon. Next, S bit RD read bar read signal is equal to P1.0. That means the read bar signal pin I am connecting to the port 1.0. Next, S bit INTR is equal to P1.2. So I am connecting INTR pin of ADC with the second pin of the microcontroller, port 1. So P1.2 of the microcontroller. Then void delay function. So void delay unsigned int milliseconds. So we are generating the delay in the milliseconds. Open the braces. Next int I comma j for I is equal to 0 colon I less than millisecond colon I plus plus. So close the for loop, and again I am writing the for loop for generating the delay in the milliseconds. So j is equal to 0 colon j less than 1275 colon j plus plus. Okay, close the for loop. Next, write the ADC function void ADC. So this void ADC function is to read the inputs from the ADC and display the output on the LEDs. So we are connecting the LEDs at the output. So we are observing the output on the LEDs. So read is equal to 1 colon write is equal to 0 colon delay of 1 colon. Next write signal is equal to 1 while taking the while loop INTR is equal to 1. So we are checking whether the INTR pin is equal to 1 or not. Then read bar RD is equal to 0. Then output equal to input. Next delay. Next INTR is equal to 1. Close the ADC function. Then void main function void main. Open the main function. Next input is equal to 0xFF column. So that means the input port, so P2 we are defining as the input. So FF means all ones. So 1 indicates the input and 0 indicates the output. While of 1 then open the braces ADC function Okay, so this is a program for interfacing of ADC. So after written program, we have to save the file with the file name and as extension as a .c. Click on save. So after that, add this file to our project. So click on source group, right click, add existing files to source group. Then click on add ADC. After that, click on add so that this C file will be added to our project. So next, click on target, right click, options. So on default, it is showing the 40 MHz crystal oscillator frequency, but the actual crystal oscillator frequency is 11.0592 for 8051 microcontroller. And after that, click on output and check in create hex file. So it will create a hex file. So this hex file we can dump into the hardware, and also we can verify the output by dumping this hex file into the microcontroller. So click on OK, and after that build the target. So go to the project and click on build target. So if any errors are there, we have to rectify the errors. So the when you are defining the ports, we have to write the capital P's. Click on save and rebuild. So the program contains 0 errors and 0 warnings. So hex file is created. So hex file you can see on the folder where you have created. So this is ADC. So hex file created. So this hex file we are going to dump into the 8051 microcontroller in the Proteus software. So for that, open the Proteus software. So click on new project. So give the file name ADC interfacing. Next, give the path where you have to store that project. I'm saving the project on the desktop, creating one folder, ADC interfacing. So select the folder, click on new project and then click on next. Here click on create a schematic from the selected template and do not create PCB. So here the PCB layout is not required. So we are selecting do not create PCB layout. Click on next and click on create firmware project. Select the family 8051 and controller 80C51 and compiler keel for 8051. After that click on next and click on finish. So open the schematic capture and here microcontroller 8051 is there. So we are going to interface the ADC. So ADC 0804. So click on this component mode, and after that select the P and type the IC name here, ADC 0804. So this is a 8-bit microprocessor compatible ADC 8-bit. So select OK and drop here. So this is a ADC. So here, so port 0 is the output. So the port 0, it doesn't have internal pull-up resistor, so we need to connect the external pull-up resistors. So pick up the external pull-up resistor, RES pack. So 8 pin, 8-way resistor. Click on OK and drop here and connect the port 0.0 to the second pin. So connect the P0.0 to the second pin and P0.1 to the third pin respectively. Connect all the pins. And the first pin is connected to the VCC. And here connect some default pins here. So I am connecting this to the port 0.0, next 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. So this is not required. So total we have connected 8 pins. And now connect the ADC 0808. And connect the ADC 0808 pins to the port 2. So port 2 is the input. So port 2 is the input. So connect the VCC to the VCC of the ADC 20th pin. So 20th pin connect to the VCC and 18th pin of ADC we are connecting to the P2.0. P2.0. Next to P2.1 connecting to the first pin, 17th pin of the ADC, and P2.2 connected to the 16th pin of the ADC. So like that connect all the pins to the ADC. So the pin numbers for the pin numbers 11, 12, 13, 14, 15, 16, 17, 18. So these are all the inputs. So these are all the inputs for this ADC. So the same names we are giving to the pins here. So terminal. So string name is the we are giving 11. So this is 18 and this is the 11th. So that means the pins from 11 to 18 in the ADC are connected to this port P0.0 to P0.7. So this is 11th pin and this is the 12th pin, 13th pin, 14, 15, 16, 17 and 18. So these pins we are connecting to the LEDs through some resistor. So take the 8 LEDs. So take the LED. So take the 8 LEDs. And take the resistors. Take the resistor. So now connect the one end of the resistor to the anode of the diode. And connect all the cathodes of all the diodes together and connect to the ground. So we have connected all the cathodes of the diodes together and we are connecting to the ground. So after that, connect some default pins here. So connect these pins to the another end of the resistors. And give the name for all the default terminals. So this is 11, 12, 13, 15, 16, 17, 18. So these are the default pins so that the physical connection is not required. So that means see here. So here the 11th pin is defined here. So this 11th pin it is connected to the here. So these are the default terminals. So that's why the physical connection is not required. And after that, coming to the DAC. So take one potentiometer and drop here. So one one terminal of a potentiometer connect to the VCC. Another terminal connected to the ground, and the middle terminal of the potentiometer connected to the V in plus. That means a sixth pin of the ADC. And CS bar. So CS bar pin it is connected to the ground. CS bar it is connected to the ground. And here two types of grounds are there, A ground and D ground. These are also connected to the ground. And also seventh pin also connecting to the ground. Next, the read pin is connected to the P1.0 and the write pin is connected to the 1.1 and the interrupt pin is connecting to the 1.2. And here take one resistor and take one more capacitor and give a connection. and connect the another terminal of the capacitor to the ground. And the another terminal of the resistor connected to the clock in, and one end is connected to the clock in and the other end of the resistor is connected to the clock or, that means 19th pin of the ADC. So we have connected all the pins of the ADC. So we have connected all the hardware connections, and now we need to dump the program. So now we are going to dump the program. So double click on the microcontroller and upload the hex file. Okay, and start running. So see here, this is a potentiometer, and here we can change the resistance here. So this is a analog value, and this analog value we are going to convert into the digital. Suppose if you keep 0%, that means it corresponds to the all the zeros in the binary. So see the output here. So when 0% is there, when 0% analog input is given, then the corresponding the output the corresponding digital output is the 0, because here all the LEDs are in the off position. That means all are zeros. The off LED, it indicates the logic 0. So all are zeros. Similarly, so now I am changing the input analog input value to the 50%. So 50%. So now the analog input value is the 50%. That means it corresponding to the digital output 128. So see the output here. So here the 11th pin, so 11th bit, that means P 0.7. So this is a MSB. So this is a MSB. So only MSB LED is on. That means if you represent 0 0 0 0 0 0 0 1, so this is a 1. So this is a MSB and this is a LSB. So that means 1 0 0 0 0 0 0 0. So that means this value of this is the 128. And similarly, if the analog input value, if you keep 100%, so if I keep the input 100%, then the output will be all LEDs are on. That means all are ones. So if the all the output states are 1, then that corresponding to the 256 levels. 256. The binary value is the 256. So see the input value also here. So the potentiometer I have kept to the 100% of the input. So the corresponding output is the all LEDs are on. So we have seen the hardware connections and how to dump the hex file into the hardware, and the same hex file we can also execute by using the Proteus software. So in this way we are interfacing the analog to digital converter with 8051 microcontroller. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.